All right, let's get right into it. We're going to peek under the hood of the engine that's about to power the next generation of AI tools, the ones you use every single day. We are talking about a seriously massive hardware leap, NVIDIA's new Blackwell B200 architecture. So yeah, let's dive in.
But before we get to the solution, let's talk about the problem. And it's a big one. Is AI hitting a performance wall? You know, it's a real concern. All those amazing models we love, the ones that generate images or write code or answer our questions, they're getting exponentially more complex. And their hunger for computing power, it's becoming a huge challenge for what comes next.
So in this explainer, we're going to break down exactly how NVIDIA is tackling this. We'll start with AI's crazy appetite for power, then check out Blackwell's smarter design, see just how big of a performance leap we're talking about, and figure out what it means for the apps you use. We'll also get real about the trade-offs, and then wrap up with one big takeaway.
Okay, so let's jump into Section 1, AI's insatiable appetite. This is all about why these bigger, more capable AI models are just screaming for a better engine to run on.
So here's the core of the issue. A key research paper on this talks about the overcoming demands of exascale computing and machine learning. Now, what does that actually mean? Well, in plain English, our AI models are getting so big and so hungry for data that our current hardware, it's like trying to fuel a rocket with a garden hose. It just can't keep up. And that's creating this huge bottleneck that could seriously slow down the next wave of AI innovation.
And that brings us right to Section 2, Blackwell's smarter design. You can think of this as the hero of our story. It's this innovative new blueprint designed to smash right through that performance wall.
One of Blackwell's biggest tricks is its 5th-generation tensor cores. Simply put, these are super specialized parts of the GPU, built to do one thing and one thing only: absolutely crush the kind of math that AI runs on.
Here's a good way to think about it. A normal computer processor is like a general workshop. You know, it can build pretty much anything, but it takes time. A tensor core, on the other hand, is like a custom-built, hyper-efficient assembly line designed to do one thing, AI math, at just a blinding speed. It is all about specialization. The second big idea here is all about being smarter with numbers. It's a concept called floating point precision. This is basically the level of detail a computer uses for its math. What makes Blackwell so clever is that it's a master at using lower precision formats, things like FP8 and FP4. It's kind of like trading a tiny bit of detail for a massive gain in speed.
So for instance, high precision is like a detailed to-the-millimeter architectural blueprint. It's perfect, but it is slow to draw. Low precision, that's more like a quick sketch on a napkin. It gets the main idea across instantly. And what researchers are finding is that for a lot of AI tasks, that quick napkin sketch is totally good enough, and it gets the job done way, way faster.
Okay, now for the really exciting part, the generational leap. We're going to put the Blackwell B200 head-to-head with the last generation and look at the actual numbers that show just how big of a breakthrough this really is.
So let's set the stage here. On one side, you've got the previous generation, the H200, which, let's be honest, was already a monster of a chip. And on the other, the new B200. The question is, how much better is it really? Let's find out.
First up, let's talk about raw speed. For the kind of complex math that fuels AI, the B200 is 1.56 times faster. Now just let that sink in for a second. That's over a 50% jump in performance in a single generation. That is a massive leap.
But you know, raw power is only half the story. It's also way smarter. The B200 is 42% more energy efficient. That means it's doing a whole lot more work with less electricity, which is absolutely critical when you realize some AI data centers use as much power as a small city. Okay, but this next number, this might be the most important one of all, a 58% reduction in memory access latency. Now that is the true game changer here. It means the chip spends way, way less time just sitting around waiting for data. So why is that such a big deal? Well, for years, programmers have had to literally design their AI algorithms around this waiting time. It was a fundamental constraint. But now, with that bottleneck pretty much smashed, it opens the door for completely new, more efficient ways to build AI. It's why the researchers say this will fundamentally change optimal algorithm design strategies.
And wow, this chart just lays it out perfectly. You can see the H200 baseline there on the left, and then look at the B200 on the right just soaring past it. Seeing it like this really drives home just how huge this improvement is. So let's move on to Section 4 and see how this all connects, from chip to application. This is where we tie these amazing numbers back to the AI tools you might actually be using right now.
So, what does this all mean for you? Well, it means training the next big thing. Maybe something like a GPT-5 gets a lot faster, a lot more feasible. It means the tools you use for generating images and video, they're going to get quicker and way more detailed. And because of that huge drop in memory latency, completely new types of AI algorithms are now on the table. And all of this happens while using less energy. Pretty cool, right?
But look, with any huge leap forward, there's no magic bullet. So Section 5 is all about being honest and acknowledging the real-world challenges and trade-offs that come with all this new power.
Of course, a jump this big brings its own set of hurdles. First off, this is cutting-edge stuff, and that means it's going to cost more. Second, to really unlock that 58% latency drop, the whole software world, from programming languages to AI frameworks, has to catch up. And yeah, while the B200 is more efficient, its sheer power means it still needs massive cooling and energy to run. And at the end of the day, its success really depends on developers actually embracing these new tools and rethinking how they build AI.
And that leads us to our final section, your memorable takeaway. If you only remember one thing from all of this, this should probably be it.
So here's the bottom line. The Blackwell B200 is not just an incremental speed bump. Not at all. By attacking these core problems like memory latency so aggressively, it is fundamentally changing the rules of the game. It isn't just about making the AI we have today faster. It's about letting developers design completely new kinds of AI that just weren't even possible before.
Which leaves us with one final big question. For decades, developers built their algorithms around the limitations of the hardware. But now that those barriers are starting to crumble, what are we going to build next?